Hi guys, welcome back to my channel. For today's video, we're going to have a discussion about the chapter summary for chapter 9, which is the all about transport layer. So, data networks and the internet support than a human network. By supplying reliable communication between people on a single device, people can use multiple applications and services such as email, the web, and instant messaging to send messages or retrieve information. Data from each of these applications is packaged, transported, and delivered to the appropriate application on the destination in device. The processes described in the OSI transport layer accept data from the application layer and prepare it for addressing at the network layer. A source computer communicates with its receiving computer to decide how to break up data into segments, how to make sure none of the segments get lost, and how to verify all the segments arrive. When thinking about the transport layer, think of a shipping department preparing a single order of multiple packages for delivery. So, the role of the transport layer is the transport layer is responsible for establishing a temporary communication session between two applications and delivering data between them. An application generates data that is sent from an application on a source host to an application on a destination host. This is without regard to the destination host type. This is the media over which the data must travel. Um, the path taken by the data, the congestions on the link, or the size of the network. As shown in the figure, the transport layer is the link between the application layer and the lower layers that are responsible for network transmission. Kuya Rayvan! Earphone. Hindi, earphone. Tracking individual conversations. Pwede mo earphone. At the transport layer, each set of data flowing between a source application and a destination application is known as a conversion. So, we also tackle about conversation multiplexing. Sending some types of data, for example, a streaming video across a network, as one complete communication stream can consume all of the available bandwidth. This will then prevent other communications from occurring at the same time. It will also make error recovery and retransmission of damaged data difficult. Transport layer reliability. The transport layer is also responsible for managing reliability requirements of a conversation. Different applications have different transport reliability requirements. IP is concerned only with this structure, addressing and routing of packets. IP does not specify how the delivery or transportation of the packets takes place. Transport protocols specify how to transfer messages between hosts. TCP and IP provides the two transport layer protocols. Transmission control protocol, as shown in the figure, IP uses these transport protocols to enable hosts to communicate and transfer data. TCP is considered as a reliable, full-featured transport layer protocol. UDP. While the TCP reliability functions provide more robust communication between applications, they also incur additional overhead and possible delays in transmission. There is a trade-off between the value of reliability and the burden it places on network resources. Adding overhead to ensure reliability for some applications could reduce the usefulness of the application and can even be detrimental. In such cases, UDP is a better transport protocol. UDP provides the basic functions for delivering data segments between appropriate applications with very little overhead and data checking. UDP is stateless protocol, meaning neither the client nor the server is obligated to keep track of the state of the communication session. If reliability is required when using UDP as the transport protocol, it must be handled with the application. We also tackle the TCP server processes. Each application process running on the server is configured to use a port number, either by default or manually by a system administrator. An individual server cannot have two services assigned to the same port number within the same transport layer services. TCP reliability order delivery was also been in this chapter. TCP segments may arrive at their destination out of order. For the original message to be understood by the recipient, the data in these segments is reassembled into the original order. Sequence numbers are assigned in the header of each packet to achieve this goal. The sequence number represents the first data byte of the TCP segment. So, Chapter 9 began with an overview of the purpose of Cisco iOS access list and their role in filtering network traffic. This includes a look at the order in which access lists are evaluated, the different types of access lists that exist, standard and extended, as well as the different ways in which access lists are applied to the router interface. And a look at the standard IP access list outline the ability to filter traffic based on the source IP address of a packet. The access list command was introduced for the purpose of adding entries to an access list, as was the access group command, which is used to add standard and extended access list to an interface. A look at wildcard masking explained how groups of computers could be specified within an access list. An overview of extended IP access list provided perspective on the more granular level of filtering control that these access lists provide by source and destination IP address, as well as by protocol and port number. So, that's all, guys, for this day, and I hope that you learn about this video about in chapter 9, which is the transport layer. And see you on my next video, guys. Thank you for watching. Please don't forget to subscribe and click the notification bell so that you will be updated on my other videos that will be uploaded. Bye, guys!